Okay, first of all, try this question. Y equals ex multiplied by cos x. So we should remind these things first. Okay, we should remind these things for as a revision. Please differentiate this first. Please differentiate this. Okay, Sophie, did you do this? Yeah. What about Sadev? Sadev, did you do this? Okay. Now this is we should get the dy over dx. Okay, we should get the dy over dx. Dy over dx. This is a multiplication. This is a product of two functions. So we should select a one function. It is ex, and we should differentiate the remaining function with the subject of x. Plus, now I'm getting the other function freely, and I differentiate the remaining function. So the answer is ex. The differentiation of cos x with respect to the subject x is minus sin x, but this should be right in a bracket, otherwise you will subtract ex and sin x. Plus, this is cos x, it is okay. The differentiation of ex is always ex. Then what's happened? Here ex cos x, I write this in here, and this is minus, no, minus ex sin x. Okay, then after that we can take ex out, then cos x minus sin x. I pull out ex because ex is common term for this. You also make your final answer like this in this format. Please make your final answer. Okay, hurry up. And the other question is the second question. Y equals, okay, y equals tan inverse half x. Y equals tan inverse half x. Try that. Okay, I will erase this. Now, you should remind what is the differentiation of tan inverse x first. What is the differentiation of tan inverse x, Putha? If y equals tan inverse x, then dy over dx equals to 1 over 1 plus x squared. So what happens to here? When we get dy over dx here, 1 over 1 plus, we should set the square for the entire thing in this tan inverse. So write entire half x and make it squared. Now we can simplify. 1 plus x should be squared separately, 2 should be squared separately. It is 4. Square of 2 is 4. No? Then we can get a common difference here. Both sides should be multiplied by 4. Then this is 4 plus x squared, and there is a denominator in 4. This is comes to the numerator. Now the answer is this 4 over 4 plus x squared. Did you get that? Okay. Are you clear how I get this 4 to this? Okay. Yeah. Cos inverse. Next question. Cos inverse x cube minus 1. Cos inverse x cube minus 1. Next question. Next question. Sin inverse cos x. Y equals sin inverse cos x. Do all things, huh? Okay. Other question. Y equals tan inverse ax plus b. Tan inverse ax plus b. AC minus b squared is square root. Next one. Okay. In what problem are you? This or this or this? First term. Okay. Sadev? In what question are you now? In what question are you now? In this y equals cos inverse. Okay. We'll do that. Y equals cos inverse x cube minus 1. So we are going to differentiate this. dy over dx. First, we should differentiate with a cos inverse function. After that, we should differentiate this function that is inside of the inverse trigonometric function. First, we should give priority to differentiate. We should give priority to differentiate. Okay, we should give priority to differentiate inverse trigonometric function. So, it is, we know, minus 1 over 1 minus x cube minus 1 squared, and there is a square root also. How we get that? How we get that? We know what is the differentiation of cos inverse x, no? What is the differentiation of cos inverse x? I will write that also in here. See, if y equals cos inverse x, then dy over dx is, okay, then dy over dx is minus 1 over 1 minus x squared square root. Putha, I write in these things by my memory. Okay, so I keep in these things in my mind. Okay, so when the problem is comes, my mind is automatically processing. So you also work like that. Okay, in this our combined mathematics paper, we should take uh, decisions very fastly. So that's the reason I think this will okay, but and we have to differentiate the inside functions also, Nabhuta. Now we differentiate cos inverse function, minus 1 over square root 1 minus the square of this. Now we are jumping into the function inside of the trigonometric function. So x squared minus 1, it is 3x squared, Putha. It is 3x squared. So what's the final answer? Minus 3x squared here, like this. If you want, you can apply difference of two squares to these, but in here it is not needed. In some problems, they are asking to show that some result. They give the result and they request us to show that. Okay, they request us to show that. So in such places, you should simplify further. You should continue the simplification further until we get the answer that they request. So in such places, you can get the help of these difference of two square and something. So I do that also. We can apply this 1 minus, see, 1 minus x cube minus 1 squared. Okay, how we apply difference of two squares here? It like this, 1 minus x cube minus 1, 1 plus x cube minus 1. What happens? Yeah, it's simplified. 1 minus x cube and minus minus, it is plus 1. So 1 plus x cube and this is minus 1. So minus 1 will cut off. This one and this one becomes 2 and this is minus x cube, 2 minus x cube and just only x cube. So we can write, if we want, that 3x squared over inside of the square root, we can write this. So in your answer sheet, you should do this simplification in a side, and this also should be included in your answer sheet, and you can replace this with this. Okay, now it is x cube. So can we do something here? We can do a simple simplification here. Okay, see this, minus 3x squared. So I will, because this is a multiplication, I will give square roots separately. So 2 minus x squared square root should be multiplied with square root of x cube. So what is the square root of x cube? Square root of x cube means, Putha, the half power of x cube. So it means x to the power 3 over 2. Okay, please write these things by a side if in your answer paper, and you can replace this x to the power 3 over 2. And after that, you can do this 2 minus x cube square root, and you can simplify this x squared and x to the power 3 over 2. How we simplify? X squared into x to the power minus 3 over 2. I get this x to the power 3 over 2 to upper layer. Then it becomes the power is negative. Then answer is, we know the answer is here, 2 plus minus 3 over 2. So uh, it is 2 minus 3 over 2 means we can get a common denominator here. 2 into 2 is 4, minus 3 is 1 and 2. So it is half. Then it is, we can apply a root x here. So this is the final answer. If we simplify further, did you get that? I think there are some simplification methods here. Okay, so it can be not understand these simplification methods. So ask me and clarify those things and go ahead. The next question is this sine inverse cos x. But before that question, before this question, you should clarify these all these simplification methods and how we get this final answer. Okay, then give you ideas. Give you ideas. How did you get this, or are you stuck with this path or something? Hi. Did you give some messages or okay? No, sir. Didn't but understood now. Yeah. Okay. Write these things, huh? Okay. Write all steps. After you complete these all steps, please update me and go to the next one. Okay, can I erase the board? Please raise hand and give me the message. Okay, I think I can erase the board. What about Sandev? I think I can erase the board, no? Okay. So you should apply those smart simplification techniques, huh? You should apply those smart simplification techniques. And we have 1 year. We have 1 year to work hard. Okay, we have 1 year to work hard. So we have to plan our uh, remaining time, and we should do a large work, huge work we should do for combined and physics. I will always support you. In this week also, I'm very busy. Okay, because I did some individual classes in my town also. That's the reason. So I go to this question. Y equals sine inverse cos x. So there are two functions. One function is sine inverse function, other function is cos function. So when we get dy over dx, first we should differentiate sine inverse function. It is 1 over 1 minus the square of this cos squared x square root. Puta, what is 1 minus cos squared x? What is 1 minus cos squared x? It is sine squared x. Okay, 1 minus cos squared x. It is sine squared x. I think this will useful for this simplification here. So this is not over. We should multiply with the differentiation of the function inside of sine inverse. So we should jump out. We should jump out into the function of a function. So it is cos x. The differentiation of cos x, it is, we know, it is sine x. Okay, then in upper layer, there is minus sine x. In lower layer, we know this, when we get the square root of this, it is sine x, no puta. So there are no relationship with this, huh? Then this is also, it is very good answer. We getting, no? Yeah, what is that? It is minus 1. Nice. Okay. Did you get that? Okay. Okay. Now move into the third question. It's very interesting, huh? Okay. What about this question now? Final one. It is y equals tan inverse x plus b. Tan inverse ax plus b over ac minus b squared. Don't worry, these are constant. A, C, B, all of three are constant. Therefore, this function also constant. So don't worry about that. Only variable is x. So how we get dy over dx here? Is same as 1 over 1 plus square of this. We should square ax plus b separately and ac minus b squared square root is separately. And after that, we should jump off into this function. That's the problem. Now, this is a differentiation of a division. No, not. No. This is not a differentiation of a division, because we can pull out this AC minus B squared square root because it is a constant, Pudha, because it is a constant. Now we should differentiate AX plus B, so it is A. It is only A, no? The differentiation of B is 0. The differentiation of AX is just A. So this is the final answer, and we should get this. We should get a common denominator here. AC minus, C, it is AC minus B squared, no? Because this is a square root. The square root of square root of square, the square of this square root is just remove in all things. So we should only multiply this with this AC minus B squared to get common denominator. Then this is AC minus B squared plus this is, we can expand this ax squared and 2 into ax into b plus b squared. I just expand this. I saw this minus b squared and b squared is cut off. Oh my god. All these things are in here. No, so there is a 1 here, 1 above, and the common denominator is AC minus B squared. So there is a 1 all above this one, and this is multiplied by A over AC minus B squared square root. Then we can get this AC minus B squared into this upper layer. Now what happens? AC minus B squared is here. In this down layer, it is AC. Okay, it is AC plus A squared x squared, this, and here 2axb, and it should be multiplied with a, and there is AC minus B squared square root also remaining here. So this is the final answer, Uta. This is the final answer. So do that. Then have you cleared it? Did you get it? Is it okay? And if you have some questions or something, please tell me. Yeah. Okay, you got it. Sophie, did I teach you this? The differentiation of the function lnx? Did I teach this about lnx? And did I teach this Is it ln x is the logarithm of x to the base e? Please tell me. I think I teach them. Yeah. A little bit means a little. That's why I ask. Yeah. Okay then. Can I erase this board? Can I erase the board now? Can I erase the board? Okay. Can I erase the board now? It's okay. Okay. Okay then. Uh, in our teacher's guide, okay, in our teacher's guide, they are requesting our competency level describes natural logarithmic function. Okay. They ask describes natural logarithmic function. It's a way, one competency describes natural logarithmic function, and under that properties of natural logarithmic function. Okay. And ln x ex. Okay, they requesting these competencies. Under this they asking what is about the properties of natural logarithmic function, and ex and ln x, and you should know the ln x is equal to the logarithmic of x to the base e, and they request this the differentiation of ln x with respect to the subject of x is 1 over x. They gives us some competencies you should complete. So please check have any doubts in these points. Please check have any doubts in these points. This is 1 over x and x should be greater than 0. Always this condition you should write here when you get this differentiation. Okay, when you get this differentiation you should write x is greater than 0 and x is not equal to 0, because there is 1 over x here. So when you write those things you should write that. So the next thing is they requesting is graph of ln x. Okay, the graph of ln x. Sophie, please update me. Did we draw the graphs of ln x? I can't remember. Please check you in your notes whether we draw the graphs of ln x. And after that, I think the today lesson is the final point that they're requesting the definition of, I not teach this. Okay, definition of a to the power x. Okay, we differentiate x to the power 2, x to the power 3, x to the power a. How we differentiate x to the power n with respect to the subject of x? It is n x n minus 1. That is how we differentiate these types questions. It's x to the power a. Now they are requesting the differentiation and definition of a to the power x. Now x is the power. Now power is variable. In here power is not variable. Power is just constant. So they are requesting the differentiation of a to the power x and its derivative and its derivative. So I think the today lesson is this. But I want to know, I want to confirm whether we do the graph of ln x, not log graphs. Okay. Okay then. Okay then we should write the subtopic. graphs of ln x. Okay, please draw the please put the topic graphs of ln x. Okay, then check these things. Are you okay with these things? I'm going to erase those things. That's why. Okay, graphs of ln x. Then it is y equals ln x. Okay, y equals ln x. So we should check what happens to y. What happens to y when x equals 0? Can you guess? When x equals 0, y is ln 0. What's the value of ln 0, Puta? If you know, please give me the answer. What's the answer of ln 0? When x is equal to 0, the answer is ln 0. ln 0 means logarithm of 0 to the base e. So how we get that? Anyone who know? Sophie, you don't know? How we get ln 0? Otherwise, it is equal to the logarithm of 0 to the base of e. Hello, Sophie, do you know how to do that? Yeah, to prove ln x differentiation. Sure. Yeah, sure. I will do that. And what is the answer of this? If you don't know, please tell me. You don't know that. Yeah, okay. How we get these type functions? So, see, we want to find Sadev. Do you know? You not giving any answers, no? So we have to find logarithm of 0 to the base e, no? This is ln 0. So get we should get a symbol for this. So now we should find x. Now we can transform this logarithmic form into index form. Okay, transform this logarithmic form into index form. Then how we transform that? E to the power x equals 0. Is it okay transforming this logarithmic form into index form? Is it okay for you? Transform logarithmic form into index form? Is it okay? Okay, then can you guess what's the value of x is? What should be the value of x? What should be the value of x? 0. No, Buddha. What happens to the, okay, then e to the power 0. We know that, yeah, if we get 0th power of any number, it becomes 1. So it will be wrong. So what's the value of x? Anyone? Okay. When x going to 0, the y is going to ln 0. Okay. See, Puta, I'm going to find what is x. Now this is 0. This is 0 means we can write this as e to the power minus 6. See? We can write this as e to the power. Yeah, it's minus infinity. X is minus infinity. How we get that? See, if x equals minus infinity, just substitute. Now it becomes e to the power minus infinity. Now we can write this as e to the power infinity. E to the power infinity is infinity. So 1 over infinity is 0. Now it satisfied. So The answer of this is minus infinity. When x equals to 0, y is to minus infinity. Okay. Now what happens to this graph when x goes to infinity? Shall we check? The y is equals to ln infinity. Put ln infinity is infinity. Yeah? Ln infinity is infinity. Y is going to infinity. So that also okay. 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 Now there is a special point in here also. Okay. That is when y equals 0, what is the value of x? When y equals 0, what's the value of x? Always you should know these 3 points about y equals ln x. Always you should know about these points of y equals ln x. Okay, after that you can figure out what the graph of y equals ln x is. So don't find other points. Okay, you should remind these points. What happens to y when x equals 0? What happens to uh, y when x equals infinity? And sure, definitely you should find when y equals 0, what happens to x? See, we can check. This is y equals ln x now. So now y equals 0, then this is logarithmic of x to the base of e. Yeah, it's not infinity, Sophie. Please see. Now I transform this into the index form, then e to the power 0 is equals to x. Now what is the answer? X equals 1. Okay then. Okay. Write these things and get these points very quickly. After that, we can draw the graph. Okay, please get these things into your paper and write these points very clearly. Yeah? You should write these points very clearly by a side. Do these calculations by a side and get these 3 points very clearly. Yeah? And uh, keep this simplification in this box. I think you also box like this. Okay, bound y equals ln x, then now this is 0 and ln is logarithmic of x to the base of e. Then I will transform this into the index form. Then now e to the power 0 equals x. Now x equals 1. So that is how I get that. Please hurry up and quickly update these things. Okay, we should know about deep mathematics to face our combined maths paper successfully. After you done those things, please update me. Okay. Hello. Okay. Did you finish these things? Okay, sure. Take your time. Okay. I will erase these things, huh? Because now we should draw the graph. Okay, now we should draw the graph. Okay. Okay, how we draw the graph now? See, this is y, this is x. When x equals to 0, see, when x equals to 0, y is at negative infinity. When y is 0, x is equals to 1. So this is also a point. When x goes to infinity, y also goes to infinity. So this slash should be like that, no? This is the type of graph. This is asymptote. Okay. This is a asymptote. Okay, draw that. If you have any doubts, tell me. Yeah? Okay. Don't touch these things. Huh? Don't touch this curve with the y-axis. Okay. Don't touch that curve with the y-axis. Okay. Now, for negative x values, this is not working. Y equals ln x is not defined. No? Y equals ln x is not defined for negative x-axis. Okay.
Recording in progress.
Okay then. Please draw this. Can I erase these things? Can I erase these things? Okay. So for the values of negative values for x, okay, for the negative values of x, it's not working. So there is a domain and range for this function. So we should write that also. Please wait. So what's the domain and range for y equals ln x? Y equals ln x. I teach you how we get the domain and range. Domain is the what's the domain? Domain is the range of x. X is range from 0 to positive infinity. X is range from 0 to positive infinity. No? So it means this means the negative values of x. For the negative values of x, graph does not exist. Did you understand that? The range is, we saw that, from minus infinity The range means y, yeah? This is x. Y is goes from minus infinity to positive infinity. Did you get that? Right, that also. Okay. Now there is y equals ln x. Y equals ln x, but there is a difference here. Okay, y equals ln x, but there is a difference here. We get in ln for modulus of x. Modulus of x means Puta, for minus values also this function works. Because if we get think when x is minus 1, but ln is we get in for plus 1 because the modulus of minus 1 also plus 1. Did you get that? Okay. When there is a y equals ln x, then also we should get the domain and range. Then what's the domain? Okay. For this, we should draw the graph. Now I am drawing the function of the graph of y equals ln x. Okay. I am draw the graph of y equals ln x. How we draw the graph of y equals ln x? So for the positive values of x, this will goes in this direction. Okay, this is one. For the negative values of x, this graph will go in this direction. So this is minus 1. In minus 1 also, see, if we apply ln when x equal to modulus of minus 1, the modulus of minus 1 means Puta, the modulus of minus 1 is 1. So ln 1 is 0 Puta. Okay. After we apply the modulus function for a certain number, then the magnitude of the number becomes out. So I think you have any I think you may be with some questions, with some doubts about this. So please ask me and we can discuss that. We can discuss more deeply about these things. So no any questions, no any doubts? No. Okay, then what's the domain? Now the domain is x now, 0 to infinity and 0 to negative infinity. Now when y equals ln x, how we write that? We write it like this. It is minus infinity to 0. Now if it is y equals ln x, then minus infinity to 0 and 0 to minus infinity and 0 to minus infinity, sorry, 0 to positive infinity, the union of this this is the domain, because we can't get the 0 here. Okay, when x equal to 0, both sides the y is going to negative infinity. That's the reason it not define also, no, it's not exist. So we are writing domain in like that. The range is same, minus infinity to positive infinity. What about that? Is it interesting or is it stuck? Is it stuck your mind or is it interesting? Or please tell me. Sir, the graph, can you explain, please? Sure. The graph, can you explain? I think in this side, is it okay, no? When the values of x are positive, Sophie, is it okay? When the values of x are positive, is it okay for you? Yeah. The left side. What happens to the left side? Okay. Now this is y equals ln x now. This is y equals ln x. Then we should check when x equals to 0 from the minus side. Okay, when x equals 0 from the minus side. Now see now these x values are minus. It's minus 1. Okay, this is minus 1. See, I am applying x equals minus 1 here. When x equals minus 1, what happens to y? So y equals to ln minus 1 modulus. Now what is the value of minus 1 modulus? It is 1. So y equals ln 1. This graph is reflects here. When x minus 2, when x is minus 2, it is also ln 2. So it is same to this graph. Okay, both y values are same. See, if this is x equals 2, so the relevant y value is this, and therefore this y value is also okay for when x equals minus 2. Why is it? When x equals minus 2, it is ln minus 2 modulus. What is the modulus of minus 2? It is 2. Then y equals, it is also ln 2. Did you get that? What happened to these positive x values? Okay, what happens to these positive x values of the y values relevant to these positive x values? It's all are same for these negative y values also. So okay, please wait. You send a message. I will read it. You take in. Okay, now got it. Yeah, reflecting part only. Yeah, that's reflecting the graph because it is modulus is only the magnitude, that's why. But if it is y equals ln x, if it is y equals ln x here, for the negative values of x, the graph does not exist. It means the domain is 0 to infinity, no x, negative x values. Okay. Okay, please note down these things. These are very important things. So hurry up and please update me when you write those things. Quickly, quickly, quickly. Okay, still writing. Still writing. Okay, done. Sandev, I think you're also okay, huh? Okay, then I will erase these things. Now the graph of LNX are also okay. According to teacher's guide, now the the graphs of LNX is over now. Then we can move to the other special topic. That is the differentiation of a to the power x. Right. Derivative of a to the power x. This is a special function, na? A to the power x. Derivative of a to the power x. Okay. Okay. How we differentiate a function like this? Then it is y equals a to the power x here. Okay. Now y equals a to the power x. Okay. Now think that now y equals a to the power x. We can't differentiate this directly. Okay. When there is these type of functions, when y equals x to the power n, because this is not a variable, okay, this is just a number, therefore we can easily differentiate these like getting n in front of this, n x to the power minus 1, n minus 1, the power of n minus 1. So here the variable is in the power. Please keep remind, if you have faced such a problem, okay, definitely you should apply ln for both sides. Definitely you should apply ln for both sides. So I will write that, okay, in red pen. Please wait. If you face such a problem, you should write what you should write. You should apply ln to both sides, okay. Please wait, don't write anything, huh? I want to ink fill ink to this. Please wait. Please wait, huh? Okay. If you face such a problem, if the variable is in the power position, okay, you should apply ln for both sides. You also write this in with your right pen, your red pen, for both sides. Write this step with your red pen. Okay, now what happens? Now it is ln y equals ln a to the power x. We know that when we apply ln function for here, we can get this x to this place. We can get this x to this place. Now I'm writing x ln a. This is ln y. Yeah? Now I'm differentiating this. With respect to x. Now what happens? Now this is the point. Please don't write anything. Don't write anything. Give you 100% focus for me. Not me, for this. For this. Okay. Okay. Now I am differentiating this. The differentiation of ln y is 1 over y. We should jump into the y function. Ln is the exterior function. Y is the interior function. So we have to differentiate y also with respect to x. It is dy over dx. Now, here we have to differentiate this also. How we differentiate that? What's the value? ln a is a value, okay? See, ln a is just constant. You don't bound like this. I will bound this to highlight you. ln a is just number. So the differentiation of x is 1. So answer is ln a. Then our purpose is to find dy over dx. Then dy over dx can be get multiplying this y into here. Now y ln a. So what is y ln a? We know y is a to the power x. So the answer is a to the power x into ln a. Then if y equals a to the power x, you should follow with these steps. You can't directly apply this. For as a summarization, I write this. Don't direct apply. Don't keep this into your mind and don't apply directly a to the power x. I write this as a summarization. And always you should follow the steps. Okay then. If you have any doubts, you can call me. You can ask from me. Otherwise, you can write it. After you write that, please give me an update.
You are. He is.
Okay. Hi. I still writing. Okay. Okay. Okay then. Do these questions. Examples. Y equals 2 to the power x. Y equals 2 to the power x. 4 to the y equals 4 to the power minus x squared. So many problems. Huh? 4 to the power minus x squared. X to the power x. Very interesting. Huh? X to the power x. Then 2x plus 3 to the power x squared. 2x plus 3 to the power x squared. Try those things. Then I'm erase these things. Example 1. Y equals 2 to the power x. Then dy over dx. Oh, we can't get dy over dx directly here. What we should do for such a question? What we should do when y equals 2 to the power x? What should we do? Yeah, you done? No, no, no. What should we do? Sophie, hi. Can you give the answer? What should we do? Sadev is not giving any answers. Huh? Disappointed about Sadev. What is the step? That should we do in here. Now the x is in upper side. X is not with us now. Yeah, apply ln. Yeah, we wrote it in red pen. If x is with, if x is not with us, in the incidence of x not with us, x is in upper now, x is in upper layer. Okay, at previous x is with us, but now x is x leave us. So x is in upper side. Then we should apply ln to get appointment of x. Okay, it's a joke. Huh? Ln. Now, because y is not with us now. So we should apply ln for both sides. Applying ln is just like we should apply a appointment. We should do appointment to find a friend. In later, friend is with us, but now friend is in upper layer. So we have to make an appointment to meet him or her. Like that, in previous problems, x is with us. But in here, like questions, x is in upper side. So we have to apply we have to do appointment. That appointment is applying L into both sides. Did you get that? Okay, yeah. Okay, now we can differentiate the L and y. The differentiation of L and y is 1 over y, and we should jump off into this function, and it is dy over dx. Yeah, we should get, oh my god. Before that, we have to simplify some, but no, we should get x to here, no, x ln 2. Now we can differentiate 1 over y and dy over dx, and this is just ln 2 puta, because the differentiation of x is 1. Now the dy over dx is the answer that we want to get. Now y ln 2, we know what is y puta. Y is 2 to the power x. The answer is 2 to the power x into ln 2. This is the answer. 2 to the power x into ln 2. This is the final answer. No any steps from here. After that, we should differentiate the functions which are called implict functions. Okay, what are implict functions? We'll see. Yeah? We'll see what are implict functions. So write this. What about the second question? Anyone who done? Anyone? Do you get that answer? Yeah, try. Okay. Okay. Y equals 4 to the power minus x squared. Y equals 4 to the power minus x squared. So as usual, we apply ln here. Now ln 4 to the power minus x squared. I mean x squared is now in upper layers. And don't differentiate directly, get this minus x squared into here. And this is now ln 4. Now differentiate 1 over y dy over dx is equals to ln 4 is just a number. Ln 4 is just a number. So this is minus 2x ln 4. Now dy over dx is y into minus 2x and ln4 is just a number. Ln4 is just a number. Okay, then this is the final answer is minus 2x y ln4. Ln4 is just a number. So this is the answer. The minus is somewhat long, I think. Okay, you don't write that. That's the final answer. Get that? Oh, so it's not the final answer. We should replace y. Y is 4 to the power minus x squared. 4 to the power minus x squared, and this is ln 4. It is okay now. Okay, this is the final answer. Have you get it? Finally, don't we? Yeah, that's the thing I have done. Okay, very good. You are in full of your attention. Very good. Yeah, that's the I want. That's the thing I want from you. The full attention. Okay. We have to start applied lessons in next week. Applied lessons, they are very interesting, like physics. Applied lessons are like physics. There are so many interesting lessons we can study very clearly. And so many works to us. I will help you to physics also. Okay, Sophie, I will give you the note. I think I can get the time after this week to assemble those things, and I can send you. Oh, sure. Please just wait a week. Just wait a week, 1 week, this week. Wait this week. We will finish on time now, sir. Yeah, we will be able to finish. Yeah. Sure. Oh, sure. Don't think about that. Trust me. Okay? Trust me. Because after this week, I will give my full focus for you. My only work is only for 2027, and there is in beside there are 28 batch. Only those things I do in next year. Okay? Until the finish line, we will do work. We can complete syllabus, but I mean doing work is doing questions or something, and we should do a uh, the paper class well. I mean, finally, my uni is done. Now, the academic are over now. Academics are over now. In final year, academics are over from this August. Okay, then. Have you done the third question? Okay. Yeah. Y equals x to the power x, no? We should apply ln for both side. Ln x to the power x, ln x to the power x. Then this is ln y, and getting x to here. Now x to the power ln x. Now we can differentiate 1 over y into dy over dx, 1 over y into dy over dx, and it is equals to, now we can differentiate, it is, oh, the differentiation of this is somewhat hard, because there are the two functions are this is not just a number, now pick x and differentiate this. I think it's good if I write like this, plus pick ln x and differentiate the other function. Now what's happening? Differentiation of ln x is 1 over x. Now this is ln x, and it should be multiplied with the differentiation of x is 1. So now this is 1 over y into dy over dx. No? X cancel out. Now this is 1 plus this is 1 plus this is ln x. This should be multiplied with y. This y. Now dy over dx is equals to this. Now what is y? Y is x to the power x. 1 plus ln x. This is the final answer of the differentiation of this function. Okay, now. Okay, now try with final answer, final question. Okay, do the final question. What about the condition of that final question? Have you done it or is it ongoing? They are easier. Okay. Okay, I will erase these things. Now y equals 2x plus 3 to the power of x squared. Apply ln to both sides. Ln y is equals to ln 2x plus 3 x squared. We can get x squared in front of this. Now ln 2x plus 3. Now this is ln y here. Now we can differentiate 1 over y into dy over dx, and please keep it in your mind, and please be careful. There are two functions, x squared and ln 2x plus 3. Both are, this is a x function, this is also x function. So now this ln is not just a number, it's a function. So we have to differentiate like we differentiate in a product. So pick up x squared and differentiate ln 2x plus 3. It is 1 over 2x plus 3, but don't forget to jump into this inner function. The inner function, the differentiation of 2x plus 3 is just 2, plus, now pick ln 2x plus 3 and you should multiply x, you should differentiate x squared. So differentiate x squared, the differentiation of x squared is 2x. It's okay now. Now keep 1 over y into dy over dx is as same. In here 2x squared, this is 2x squared and over 2x plus 3. Then plus there is also 2x here. I get this 2x into in front of the ln 2x plus 3. I think we should multiply all of this by y. Then we can take the value of dy over dx. Y is we should multiply y separately by all of things. 2x squared over 2x plus 3, and then y should be multiplied with this also, 2x dot ln 2x plus 3. Then what's the value of y is 2x plus 3 x squared. Now y into 2x squared over 2x plus 3, and oh no, we should substitute y. Y is 2x plus 3 power of x squared. Okay, plus in this also there is y, so it is 2x plus 3 to the power x squared, and it should be multiplied with 2x, and it is ln 2x plus 3. This is the final answer. Keep that. Okay, now okay, please write it faster. We have to move to the other important topic on this differentiation. Sir, don't we need to differentiate first x squared? What is this first x squared? First x squared. Here we differentiate it here. We first pick up this and differentiate this, and we pick up this, differentiate this as 2x. The differentiation of x squared is here as 2x. Did you mean that x squared or what x squared? You highlighted. Okay. Okay then. Can I erase the board? Have I finished it? Okay. Okay, now we are going to study a new topic. Okay. Have you heard implict functions? Sadev? Sophie? Have you heard implict functions? The word implict functions? What is the word implict functions? No. Okay. Then write the topic differentiation of implict functions. I think if you like, write it with red pen, but it's your option. No? It is optional. Differentiation of the word is. Oh my god. The ink is jumping off like. I don't know what happens here. differentiation of implict functions. Okay. Now, the first question is, what are implict functions? Write those things. What are implict functions? Now we are going to study about implict functions. Example. There is a function fx, okay, x squared plus y squared plus 3xy. Fx equals x squared plus y squared plus 3xy. Okay. Now here we know y is the we know y is the variable, the dependent variable. Okay, don't think about like fx. I will replace fx by also y. Yeah, y. See. Okay. So this is the equation now. Now this is the equation. So if I get this is a function. Okay. Now the function is this x squared plus y squared plus 3xy. So see here, we can't isolate y. Okay. If this is a 3x minus y equals 5, we can isolate y. We can get this minus 5 to here and this 5 to here, and it is 3x minus 5. We can subject y. There are some functions we can't subject y easily. There are some functions uh, there are some functions we can't subject y easily. We can't subject y easily. We can't isolate y easily. The y is the dependent variable. In physics also we know x is the independent variable, y is the dependent variable. So there are some type of function we can't isolate easily the dependent variable. We can't isolate the dependent variable easily. Those functions are we call them functions as implict functions. Okay, that's the definition of implict functions. So don't write these things. We should write the examples, but don't write anything. I think you write these things and write the answer here. Write the answer here. An implict function is a function. An implict function is a function. An implict function is a function defined by an equation. Defined by an equation. Defined by an equation where the dependent variable is 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 not isolated on one side, where the dependent variable is not isolated on one side, where the dependent variable is not isolated in one side. එක පැත්තක තනි වෙන්නේ නැති, not isolated on one side. Such functions are known as implict functions. Then write the subtopic implict differentiation. I will explain all these things by using problems, but before those things, you should write these things. Write these things. Implict differentiation. Okay. So, what are the implict differentiations? So, write the note. We can find the derivative. We can find the derivative under the implict differentiation. We can find the derivative. What is the meaning of derivative, Puta? Derivative is dy over dx. Okay, we can find the derivative and write this in brackets. We can find the derivative of an implict function. Continue this. Of an implict function. We can find the derivative dy over dx of an implict function. Of an implict function without isolating y first. Without isolating y first. Without isolating y first. Without isolating y, we can differentiate it. That's the meaning of this. Okay. Write in the same paragraph. Write in the same paragraph. We should differentiate every term in here. Right in here. In here, we should differentiate. In here, we should differentiate every term. In here, we should differentiate every term. Every term normally and apply the chain rule. Apply the chain rule. I will explain these all things with problems. Don't get panic. Differentiate every term normally and apply the chain rule. Apply the chain rule. Apply the chain rule whenever you differentiate the y term. Whenever you differentiate the y term. Okay. I will explain all of these things with an example. Okay, please wait. Now, example 1. Example 1. Y plus xy plus y squared equals 2. This is the implict function. Okay, this is the implict function. Now, they are asking from us, differentiate this. Differentiate this entire function. Differentiate this. They only say in this. It means differentiation of this entire function. Entire function means this, including this 2 also. With respect to x. So, this is an implict differentiation. So, this is an implict differentiation. Now, how we differentiate this? Normally, you can differentiate. What is the differentiation of y? It is dy over dx. What is the differentiation of this? In here, how we differentiate this? This is a product. Huh? we should use the differentiation techniques when we use in product. So pick x, differentiate this, pick y, differentiate x, it is 1. So this okay, now this okay, plus how we differentiate this? 2y and jump into the function y, it is dy over dx. 2y is differentiation of the exterior function. Now y is there. So we should have to differentiate y also, dy over dx. The differentiation of 2 is 0. That is the way how we differentiate this. You ask a question, a small help. After this, can you please repeat what is implict function? Sure. My pen finish. Oh my god. Okay, sure. Putha, implict function is a function. Implict function is a function. We can't isolate y. See this example. Y is in everywhere. Y. Okay. If you want to isolate means subjecting. If you want to subject this y, I think you should apply complex mathematical theorems. In differentiation, we define such a function as implict functions. Implict functions means we can't isolate. We can't isolate the dependent variable. Dependent variable means y, and if there is a function, we can't isolate y easily. So such a functions we known as implict functions. Pudha, did you write the note or did you miss it? Did you miss the note also? Ah, yeah. You wrote all note, no? You complete the note. I want to know. I want to confirm that. Did you complete the note? No, my God. Send me a photo of the final note that you have in the final page that you have written. Please send me a photo. Send me that photo, not for eSTEM online education. Send me to my private number because eSTEM online education is on the camera now. That WhatsApp, please. Please send me to my private number quickly. Yeah. Only this section means I defined the implict functions and all other things. I ask in that the definition of implict functions, the definition of implict functions and such things. Yeah, the definition of implict functions you missed. Only the definition of implict functions. Is it? Only the definition of implict function. Oh, please wait. I will repeat. Okay. The definition of implict function. Then Buddha, implict differentiation. There is a subtopic in yeah. There is a subtopic on implict differentiation also. You have missed all things. Yeah. Then what have I missed? Okay. After the class, send me the photo. Okay then. Then what about this? Did you get this? How we differentiate implict function? Yeah. How we differentiate implict function? Did you get this? Have you an idea? Is it okay? Now we have to subject dy over dx. Is it okay now? From this step to this step? Huh? So dy over dx, dy over dx is common for all terms. So we can pull out dy over dx here. Now 1 is remaining. In here, x is remaining. Oh, there is y now. X in here, 2y is remaining. So this function is okay. This function is okay. This function is okay. Now there is plus y here equals to 0. Now dy over dx 1 plus x plus 2y equals minus y. I got this plus side here. Now what is the answer of dy over dx? The answer of dy over dx is minus y over 1 plus x plus 2y. So this is the final answer, Buddha. Okay, if you have any question, any doubt, please ask me. Otherwise, I will go to the example number 2. Sure. You sent. I will see. So have you any questions in here? Any doubts here?
So that was face to face. So after that, I missed the definition, but as soon as possible, I came and wrote down the subject. After the subject, I took another. So become question after that, only I stopped. But then again for the next subject.
What are implict functions? A function with an equation. Yeah. Puta, Puta, in there is a what are implict functions no? So we wrote the answer. And after that, you write, we can find the derivative like for that paragraph, you put the subtopic implict differentiation in midpoint. Implict differentiation in here, in this space. Implict differentiation is the topic for this paragraph. So now it is okay. Now my question is, what about this? You send a message like no. What's no? You can't understand this. What's the meaning of that no? Okay, welcome. What's the meaning of your no? You said no, so what's that? Understood. Okay, please write it quickly. Please write this quickly. Okay. Okay, example 2. Example 2 is this. See, y dot ey equals 2. So these are the original implict functions. Can you isolate y in this equation? No, not this is not 2. This is x. Can you isolate y in one side? No, you can't. So these are implict functions. Now I think you can get the idea of implict function. So these are, we said, implict functions. So how we differentiate this? Try how we differentiate this. So you should differentiate with this with respect to separately. Separately means about this. What's that the meaning of that word separately? What's the meaning of that word separately? You should differentiate this with respect to. Differentiate with respect to x each term. Yeah, separately means like this. This is a product, no? Y, the differentiation of ey here. So these in here, see, we can't differentiate ey. We can't differentiate ey with respect to x. So we differentiate dy and apply chain rule here. Okay, apply chain rule here. Dy over dx. Did you get that? That is how we differentiate ey. Now I pick y and differentiate ey. Differentiate ey. And then I pick ey and differentiate y. Now we should differentiate x with respect to x. It is 1. So why can't we diff with respect to x? Yeah. Oh, we can't differentiate ey with respect to x puta because there are no x variables inside of ey. We can differentiate ex with respect to x. Then it is ex. This is not equals to ey. Yeah. This is not equals to ey. It's always should be x terms in the term that we going to differentiate. Okay, we can differentiate ex with respect to dx, it is ex, but we can't differentiate ey with respect to uh, uh, dx. So we have to differentiate with its subject and using chain rule. See, Puta, this is the thing we do in the jump in operation. We do in the jump in operation also. No? See, this is the thing we do here. See, what's the final answer? Y into the differentiation of ey with respect of y is ey, same ey, into y plus, so not y, dy over dx. Please be careful and don't write anything. In here, ey dot dy over dx no equals 1. Now, I wrote this step for your understanding. What we do here? Pick y, differentiate in ey. The differentiation of ey is ey and jump into this function and differentiate it, then dy over dx. That's how it come in. And this is the expanded steps. I wrote it for your understanding. Here also I pick ey and differentiate y, dy over dx. Then I can pull out dy over dx here. Now this is ey is remaining. Oh my god, this is also ey, no? So it is 1. So it means dy over dx, this is 2 ey equals 1. Now what is the final answer? Dy over dx equals to 1 over 2 ey. Okay. Oh, no, 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 no. It's wrong. It's wrong. It's wrong. It's very wrong. Huh? Please wait. I forget about this y. No. We can get dy over dx and ey. Both are common, no? Ey, dy over dx, dy over dx. But here y is remaining. Then y plus 1 equals 1. Now it's okay, no? The dy over dx equals to 1 over ey dot y plus 1. Now it's okay. That is the answer. Very sorry. After that, you can do some modification also. We can see, we can multiply this now. Then y dot ey plus ey. Then y dot ey is x here. Now 1 over x plus ey. 1 over x plus ey, no? We can write 1 over x plus ey. Is it okay? Okay, please write down these things quickly. After you finish the writings, please update me. I think it is okay now, no? Okay. Can I erase the board? Sure. Now, they are okay now. Now, this is how we differentiate implict functions. Okay. Okay. Now, the third example. X squared y plus 2xy squared plus y equals 3. Can you differentiate this? This is also implict function. Can you differentiate this? Okay. How we differentiate this? Pick x squared, differentiate y, dy over dx. And pick y, differentiate x squared, it is 2x. 2, please keep out 2. And pick x, and differentiation of y squared, it is 2y. And after we jump into the inside of the function, there is y here, then the dy over dx. Plus, now we should pick y squared, and differentiation of x is just 1. Now bracket is over. 2 is over. Plus, the differentiation of y is equals to dy over dx. The differentiation of 3 is just a constant. Therefore, differentiation is 0. So, did you get this step? What about this step here? Is it okay? Hi. Okay. Now, please notice the terms with dy over dx. This and this. Now x squared dy over dx plus y dot 2x. Now I am expanding this. It is 2x. Oh, sorry. Only this. 2x, 2y, and dy over dx plus 2y squared plus dy over dx equals to 0. Then I think it's the time, no? We should notice what are the terms with dy over dx. Now, please pull out dy over dx out. Now x squared is remaining. 2x 2y means 4xy is remaining. Here when we pull out this, a 1 is remaining. Now there are 2y squared. Don't you bound these things, and 2yx is remaining equals to 0. Now don't hesitate to write these steps. You should write all of these steps. Don't be lazy to write steps. In here we can get pull out 2y out, 2y out, then y is remaining. In here x is remaining, so it is equals to 0. Then we can get this 2y into y plus x to this side, then it becomes minus 2y into y plus x. In here this is remaining, then dy over dx is equals to, please get this entire thing to this in the denominator of here, x square plus 4xy plus 1. So how is it? Definitely you should give answer. Are you satisfied with this? Do you understand this? 2xy plus y squared, then under that x square plus 4xy plus 1. Got it? Hello, did you got it? Please give me answer. Did you got it? Yeah, write these things quickly. After you finish this, please update me. After you finish this, please update me. Okay. Fourth example, sine x squared y plus x squared y squared equals 0. Differentiate and find dy over dx. Not fine, show that. Show that dy over dx is minus 2 xy cos x squared y plus xy squared. Yeah. In denominator x squared cos x squared y plus 2x squared y. Okay, show that. Okay. First, have you done any steps in this question? Any steps in this question? Any step? Hmm? No? Tried. Oh my God. 23rd step? You are in 23rd step? My God. Third. That's why I confuse. Huh? Okay, here the first is cos x squared y. Then we should jump out into this. In this, pick x squared and y is dy over dx. And I will pick y and it is simply 2x. In here, pick x squared. The differentiation of this is 2y and dy over dx plus pick y squared. The differentiation of x squared is 2x. Anyway, this is equals to 0 now. Now we should find dy over dx here. So we should expand this. Write first dy over dx. Huh? So that is easy. Dy over dx and it is x squared. After expanding, this is cos x squared y plus cos x squared y cos x squared y multiplied by y and multiplied by 2x here plus in here also I write dy over dx and 2x squared y and here 2xy squared equals to 0. Now notice the terms with dy over dx and pull out dy over dx out and pull out dy over dx out and this is x squared cos x squared y. See, this is forming here. After I pull out dy over dx, 2x squared y is here. 2x squared y. Now the remaining things we should get off into the other side, right hand side. It is here minus 2xy. I write this 2xy and cos x squared y and this minus 2xy squared. Now what happens? I will keep this thing in this. So I am easy to get dy over dx now. It is x squared cos x squared y plus 2x squared y. In here we should get 2 out of that because in answer is 2. Then xy cos x squared y and this is plus I because I get minus 2 and it is xy squared. Okay, no, this is okay. This is how we take the answer. Okay, I confused that this the 23rd means solving. Okay, it's also very easy. Okay. Okay, now the topic is there is another topic we should move to that topic. Have you write it? Finish it? Did you finish the writing? Still writing? Differentiation, revision, homework. Sure. I will send those things in this week. Okay. Can I erase the board? Yeah, I think it is okay. No. Okay. Okay then. Oh my God. Yeah, you're correct. No. 2 weeks without homeworks and without class also. No. So don't worry. There are huge workload from this week. Okay, from this week there are huge workload for us, and we should focus our 100%. Focus 100% for the subjects. Yeah, 2 works without homework, without class also. Okay. Now, now the topic is okay. Yeah, I think in next week, on next week, our another class is in next week, and I think we can arrange a class in yesterday. I think just not yesterday. It's tomorrow. I think we can schedule, but in next week we schedule many classes. In next week, I think at least 3 classes. Yeah, at least 3 classes we can schedule in next week, and then I can give you the YouTube videos of doing extra questions of these things, of these theories. Then we can do those things. Okay. Yes, we can. Sure. Yeah. Definitely. Yeah. Definitely, we can do the classes. Uh, we will do the classes with our time. Okay, because we can't see the others. Okay, we can give the recordings for others. No, I think Sunil is always going down. No? So we'll see that. Yeah, you are right. Otherwise, we can't complete that also. You are 100% or you are right. Okay. And I will give you the plan from a video. Okay. After this week, I will make the plan of your final mission. Okay. Final, there's only 1 year. For me, except for Saturday and Sunday, Monday are other days free. Yeah, except for Saturday. Sunday and Monday. Okay. I planned I planned Wednesday and Thursday. I planned Wednesday night and Thursday night for pure and applied. For pure and applied, Wednesday night and Thursday night. And then after that, we can schedule other classes. Other classes will, yeah. Okay, we can schedule that time. And other short videos, other I mean solving some past paper points. Okay, uh, the points that are important for doing papers, those. And other thing is the paper class. Our paper class will should strong paper class. Okay, the strongness is I give you the paper and I give you the discussion, but you should write it honestly. That's the thing. Okay, we have two paper classes: physics paper class and the combined maths paper class. Okay, I will give you the physics also. Okay, there's a huge work. We have to plan that. Okay. Okay, then. You're welcome. Okay, then our new subtopic, obtaining derivatives for, like, right? Obtaining derivatives for higher orders. Obtaining derivatives for higher orders. Obtaining derivatives for higher orders. Oh, yeah. What are those higher orders now? Okay. Now, there is a derivative order. Okay, there is a derivative order. Derivative order means, think it is y equals x cube plus x squared. Then we can get dy over dx. See, dy over dx. This is the first order differentiation. So 3x squared, 2x. And after that, we can differentiate further this. How we differentiate further? 3 into 2, x plus 2. Now here we write in this as this, d squared y and dx squared. This meaning is we differentiating again y with respect to x. Okay, this is the second order differentiation. These are the higher orders. In previous sessions, we only differentiate in first order. But now we are going to differentiate higher orders. Now we are going to differentiate higher orders. See, now we are going to differentiate higher orders. We can differentiate 3 also, third order also. How we differentiate is it? Three into 2, 6. Did you understand what is this order? Did you understand what is this order? See, different. It means the different. We get a function and differentiating again and again, again and again. Then it is the order thing. Okay. Okay. First, you write this example. Then we can. Then we should write a table here about orders. Please write this quickly. Quickly write this. Did you write this? Okay, still writing, no? Okay. 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 Now we have a table here. Derivative order. Okay, first column is derivative order. The second column is how we say in it. Okay, there is a pattern in saying also. Then other column is notation. Other column is notation. Now the order is first order. How we say in that? How we say the first order? The first derivative of C, yeah? The first derivative of y with respect to x. Then what is the notation? Notation is dy over dx. We all know that. Dy over dx. Oh, we can write this as y dash. Okay, we use the symbol y dash also. Now the second order. How we write this? The second derivative of y with respect to x. Then what is the notation? D squared y dx squared. Or we can write this as y double dash. We can write this as y double dash. Did you get it? Then we can blah blah blah, and fairly we can write nth order. We differentiate it nth times. How we write? The nth derivative of y with respect to x. How we write this notation? dn y over dxn o. There should be n dashes, no? How we write that? We can't write n dashes. It's n. Yn. So you should write this table now. Don't you write the table in red pen, na? I just draw it. Okay, get this table into your paper, into your book. We say in f dash also, if the function is fx, it is f dash x, it is f double dash x, okay, or f nx, like that. We can get that. But convenient and neat when lines I read, I normally do that, but okay. In red. Oh, yeah. When needs, when lines in red, I know. Okay. Sure. You can use the red pen. Okay. Yeah. Okay. Okay then. Uh, Example 1. Y is equal to sine 2x. Okay, y is equal to sine 2x. Then you should find dy over dx and this and this. Okay, find these things. Okay. Dy over dx is cos 2x, and we should find into this inside function, and it is 2. Then it is 2 cos 2x dy over dx. Then we should find the second order differentiation, d squared y over dx squared. Now what is it? The differentiation of cos 2x is minus sine 2x. The differentiation of cos 2x is minus sine 2x, and should be then multiplied with this 2x. It should be differentiated with 2x, and it is also 2. Then the final answer is minus 2 into 2 is 4, minus 4 sine 2x. Then how we get the third order? Minus 4, and we should differentiate sine 2x is cos 2x, and after jumping off into 2x, the differentiation of 2x is 2. Then the final answer is minus 8 cos 2x. Perfect. Did you get those answers? Huh? Forgot these double lines. I forgot those double lines. Get these things. You are doing okay. Keep doing. Keep. After this, we only have 2 subtopics on differentiation to cover. The one is differentiation of parametric, otherwise parametric differentiation. The one is parametric differentiation. The other thing is one is parametric differentiation. Okay, the one is parametric differentiation. Other is what? Applications of differentiation. So the lesson is over. Applications of diff. So after that, we can move into the integration part and simultaneously with applied lessons. Okay, my applied part is better than pure, okay, because it is very close to physics. Okay, so I think I can explain applied better than pure. No, pure is not better. Pure also I can explain. Yeah, please wait. Yeah, homework questions. Okay. Sophie, I will give the homework questions into the group. I will send the homework questions into WhatsApp group. Okay. I think it is it is best because I have to give the recordings also. No? Don't worry. Yeah, I will make the applied is the most happiest part of your life is applied. Please wait. Yeah. Okay. The the more to go. The game is in future. Okay. There are applied parts also. Very interesting parts in applied. Okay. Yeah. Very interesting parts in applied. Okay. Have you get these things? Yeah, sure. Looking forward means next week, huh? We starting applied lessons in next week. Okay. Now, uh, now the other question is ex sin x. Y equals ex dot sin x. Try, yeah. Try this question also. Get higher order differentiations. Okay, get higher order differentiations. Did you finish the question? Okay. Uh, what is dy over dx? Pick ex, differentiate this. We should find into this also, but differentiation is 1. Plus pick sin x. The differentiation of ex is same as ex. Then second order. Ex, differentiation of this is sin x plus pick cos x, differentiation of this is ex. Now this is so long, huh? This is pick sin x, differentiation of ex is ex, and pick ex, differentiation of sin x is cos x. See, ex sin x, ex sin x, this is minus, this is positive cutoff, then ex cos x, ex cos x, it is 2 ex cos x. Did you get these things? Okay, Sophie, did you get these answers? Hi, are you sleeping? Yeah, oh, got that. Then this is 2 cos x. It is easy, no? No? 2, pick ex, differentiation of cos x is minus sin x, plus pick cos x, differentiation of ex is just ex. Now, to we can pull out ex out of the bracket. Then cos x minus sin x. So these are the final answers. I think you got these things, huh? Have you got these things? Okay. Hello. Yes. Okay then. Okay. Another question. There is a show that thing, huh? I give you exy equals sin x. If exy, please wait. Exy equals sin x. Ex dot y equals sin x. Then show that please wait, huh? Plus 2 dy over dx plus 2y equals 0. Try this thing. When you get the answer, please tell me you got it. Okay. If you got this answer, both you and me success today. Give a try. If you get this answer correctly, both you and me, we all are success today. Okay, try. I will very happy, yeah, if you uh, send the message. You got it. Nice. Sandeep, you give a message. Please wait. I will see that. Yeah, you got it. Well done. Congratulations. Thank you. Okay, very good. You got it. Nice. Okay, after that, Sophie, you don't panic. You just solve. Okay, take your time and solve the question. I'm waiting for you. Then Sadev, after this, the thing is we want the lesson is parametric differentiation. The other topic after that applications of differentiation. Then after that, the main lesson we have integration. We will move to the integration lesson. So okay then. So I'm waiting for the Sophie's answer. Sophie, how is going on? No any urgent, huh? You just do. Yeah, sure. You take your time and you just do. I'm waiting. We are waiting for you. We can increase the speed after that. First, we should do the question correctly. Okay, Sophie. Good luck. Well done. Okay. Now we should give this recording to uh, of other people also. So I will do this question for the recording because I should give the recording to others. No? So you do that. Perfect. So it is a sign that you are going in the correct path. You are going in the correct path. Now you should boost your speed. Okay, Sophie, you should boost your speed. Now I am discussing this. So I'm differentiating pick ex and dy over dx and pick y. The differentiation of ex, the differentiation of sine x is cos x. Then we should differentiate this again. Pick ex. Now I am differentiating second order dy over dx squared, and I pick dy over dx and differentiating ex again. Pick y. Differentiation of ex is ex. Pick ex. The differentiation of y is dy over dx. The differentiation of cos x is sin x. We can see that only the second order is there. So don't need to differentiate again. Now we should do like that. Okay, see the ex dot y is sin x. So we can substitute sin x. Not sin x. Yeah, not sin x here. Yeah. But sin x is not a way off. No, please wait. We'll see. Sin x is not cut off if we apply that. Please wait. Okay, then okay, dy over dx. Now we want this, no? So ex should be cut off. How we cut off ex? Yeah. We can substitute for sin x exy. So we should write these things again, huh? Don't hesitate to write these things. Dx squared plus dy over dx ex plus yex plus ex dy over dx. Now minus sin x is here minus exy. Now we can cut off ex. Oh, in all terms ex is there, no? Then this is d squared y over dx squared. See dy over dx and dy over dx. So it is 2 dy over dx. I think answer is there, no? And we can get this minus y into this place and it is 2y. It's okay. The final answer is okay. Okay, then I think 80% of the differentiation is over now. 80% of the differentiation is over now. Only we have the parametric differentiation. It's very easy. Parametric differentiation and the applications of differentiation. Under the applications of differentiation, we should discuss the graphs of differentiation. So after those things, we can move into the integration with doing applied lessons. We did trigonometric lessons also, but I will give you a revision trigonometry revision videos from this week. I will give you a revision videos for trigonometry. They are not live sessions. They are I record and give you. then we can do a huge work from this work, and from this week, and we should target our A in 2027. I did the whole page of, no, I can't see, the message is dropped. Yeah, your message is okay, what's the message? So I did a whole page of workings for this question, sir. Yeah, okay. Don't regret that. Okay, you did the whole page of workout, so that workout is practicing you. Okay, that workout is practicing you, and you should identify these short methods. Huh? After this, you apply these smart techniques of simplifying. Okay, you write this also, but don't worry about the your workouts, because those workouts will carry you to the A pass. Okay, so grateful for your wrongs. Okay, grateful for your errors, grateful for your long workouts. So they are the things that builds you. Okay, don't worry about those things, and study these short methods. Please need trigonometry. Yeah, definitely. I will give you the trigonometry revision from small videos. Huh? Small videos. Don't worry. Okay then. Okay. I will send the homeworks. Okay, I will send the homeworks to the WhatsApp group. Then, okay, I will give the recording also for the WhatsApp group. Then, okay, good night and work hard. More to go. There is a huge of workload, and I will give you the correct plan. Okay, don't worry, trust me. Okay, sure. Yeah, we can practice. Okay, if you have any question, you can ask from me. Otherwise, goodbye. Okay, welcome. Okay, goodbye, Sophie. Good night.